a little bit more. Now I would move more into the biosecurity aspects as indicated in my title. You could say that potentially virulent or aggressive strains, apex, have been isolated from several sources. We know that. Healthy chicken intestine, air handling systems, water systems, near house environment, etc. And this makes it, of course, very difficult to come up with some specific recommendations as to, or besides a general high level of hygiene, you could say, because they are there. The potentially aspect and the dilemma is that we do not really know which of the subtypes of coli we should focus on. And that's what we would like to be capable of doing over the years, saying that this subtypes we need focus on, this subtypes, and we can forget some of the other ones. And this is a major task. But at least we know the potentially aggressive strains are nearly everywhere associated with poultry houses. So that's why we have focused our efforts and our work very much on the parent flocks, as I just showed you the data from, due to the history and our experience. So we would very much like to look at the disinfection procedures of these hatching eggs and think that this is one of the major ways to obtain better results in the broilers and combat, of course, these vertically transmitted E. coli we see in the parents. So as part of the ProHealth project, we have really characterized a lot of bacterial flora from hatching eggs. We have been doing this together with a minor hatchery on Cyprus, and it's been a great collaboration, and we are not finished with that yet. So again, we have focused this part of the work on the disinfection procedures and the effect on bacterial load and bacterial diversity on the hatching eggs. Just a very brief introduction again to this aspect. You know that the hatcheries throughout Europe do disinfect the surface of the eggshell of the hatching eggs. They must be. What is puzzling though is that there is very, very little literature available on the efficiency of these disinfection procedures. We have really had difficulties finding out what is the effect of double infection, disinfection, single, what does it mean? And it's hardly possible to find any literature. That's striking because so much effort is performed worldwide, so many money is used on this without a very good documentation. So we were interested in getting into this. Also another scientific aspect, you could say, is that what is the diversity on this egg? Are all types of bacteria affected in the same way during this disinfection procedure? We didn't know. So it was new land for us. So we wanted to, again, investigate the impact on the disinfection on culturable bacteria by standard colony-forming units count, where we just try and grow from the eggshell. Also, again, we would like to look at the diversity, and we did that by preparing the surface of the eggs, purified DNA, and by PCR techniques, finding out the diversity, which bacteria was on the surface of this egg. We talk about three categories of eggs, and we have the very dirty eggs used in the industry, and we haven't worked a lot with those, but of course the dirty eggs and the clean hatching eggs are the one used in the hatchery. And you know, most of you, that dirty eggs may and floor eggs may be a major problem. And I don't know what you recommend the producers, but at least we say do not use them. And of course they use them. they have to. But as I will show you, they are really a risk. They have much higher bacteriological counts than the clean hatching eggs. So they do represent a major risk. What we did with our partners from Cyprus was to go in the whole procedure from the breeders to the hatchery and sample in between their disinfection procedures. So we sampled at the farm. This is the arrow showing that we sampled the eggs before any kind of cleaning disinfection procedure. And then in the hatchery, the eggs from the hatchery we sampled after the farm disinfection, after first disinfection at the hatchery, and after the last disinfections. And we did that with both normal eggs and the dirty eggs. I will not go into detail with this. The ones of you interested can always get these data from me. It's just, again, showing the different steps at the farm, at the hatchery, and where we took our samples. So, but of course this is interesting. Also, because what are the procedures used at this hatchery? You know, it may vary a lot, and you could make a major study on the different disinfection products, etc. But we are not there at this stage, at least. Now we wanted to look more at the number of procedures and the effect. This can, of course, be expanded, and we would like to do that. But this is some of the main results so far, and you can clearly see that we have the clean eggs on top here and the dirty eggs, and before disinfection we have quite a high bacterial load on these hatching eggs. Of course, the dirty eggs, again, there is significant difference on the bacterial load, and when we have the first fumigation, we have a severe or very good significant drop on the bacterial load, and after the second, even further decrease, not significant, but it still have the tendency of reducing the counts. And after a final spraying, it really works well. We get down to almost the detection level. This is colonies. We're talking about 2 and 3 colonies. So the procedures, at least, used at this hatchery were very efficient, highly efficient, and even more efficient than we've seen in Denmark under some preliminary or pilot studies we used. I think this is quite impressive, actually. Of course, you could argue here, do we need a second fumigation here? Because the difference between first and second are not that pronounced. And of course, this should be repeated and so on. But again, it may be something to be discussed in future procedures. A lot of money can be saved, etc. So this is to give you an indication where we are now with our data, and we still have a lot of analysis to do because we have had a lot of eggs involved in this very laborious work. You can imagine, I think, because all eggs have to be swapped following a specific protocol, a lot of plating, a lot of counting, etc. So we still have a lot of data handling on this, but until now we are very happy with these data because we can really see some good effects, actually. So just to conclude on this, there was a significant impact on the reduction on live bacteria on the eggshell. Before disinfection, dirty eggs was significantly the higher bacterial load. Adding a chlor wash step to the dirty eggs reduced the bacterial load to a level comparable with clean eggs, I should say. And again, the colony forming unit count does only include live bacteria. And as I will show you, we will go and look at DNA, RNA to look at traces of other bacteria. This is an indication on how this is analyzed at the moment. Again, we prepare the eggs, sample for DNA, and make some multiplex PCR where we get all the subtypes of bacterial families, genera, order, species, and so on. A major task, but we are in the process. We have the samples from all these hatching eggs we used for the cultural study, and this is just an example to show you the diversity that you're actually capable of seeing by these molecular methods. And we also see some tendencies already, and at least we see the majority of bacteria present in these samples, and the lactobacilli are very important. That's the blue, dark blue and light blue primarily, and they are probably important. This is another aspect about disinfection. Do we really want a sterile egg? Probably not. The lactobacilli associated the hatching egg may be very important to colonize the chick after hatching. So there's many aspects of this disinfection, how it affects the total load of bacteria, different subtypes. Again, I do not think we want to get rid of all bacteria associated the hatching eggs. So, and this takes a long time to analyze these data, and this was just brought in as an example to show you how it looks when we put this on graphs. So at least we do see an effect on the diversity before and after disinfection. It's not all bacteria being affected to the same way, but the significance, as I said, we are not aware of. And we need to analyze a lot on these data before we have something more substantial to say, I think. I would like to finish by bringing in another aspect of the E. coli that we work a lot with, and also is associated with the ProHealth project. Perhaps not that directly, but we use this method a lot to, again, understand the findings we see concerning the different subtypes of E. coli and their importance. But we developed this model, a model to study, an in vivo model, to study the virulence of E. coli in the oviduct of chickens. And the main reason, of course, being that we do know that some subtypes of E. coli are capable of causing much more disease than others. But we didn't have a good model when we talk about the oviduct. So we started that 2 years ago, developing a model due to our understanding of salpingitis and peritonitis, that it is an ascending infection from the cloaca. And again, we needed this model to study both aspects associated the hen, but also the bacteria, of course. But we didn't have any models, so we tried to be proactive here and started out taking some layer chickens, put them under anesthesia, isoflurane. It works very well with avian species. So this is fully anesthetized with a mask and placed on the right side, and this is just a small line with a pen to show that this is the place where we do the incision for localization of the oviduct of this sleeping chick. So after this small incision, we can drag out the oviduct, the salpings, and we can inject different coli, different subtypes, well-characterized E. coli, and following this injection, inoculation, we put the salpings back, and we make a few sutures, and we let the chicken wake up again and place it in its pen. And we can follow it for these days that we need, and see how this infection in the oviduct is developing over that time. And we published that model, as you see, in 2014, if you're interested. We did some initial worked to see whether we really were capable of injecting the bacteria at the same site of the oviduct every single time. Was it a reproducible method? So we just used ink in the first birds that we used. And as you see here, for these first 4 birds here, we do place it very similar places, you could say 5 centimeters distal to the cloaca, as you see here on the right, and it progresses quite rapidly, this ink in cranial direction, and again towards the peritoneal cavity, you could say. This is another issue, why it does that very rapidly. We do not know. I think there's quite a lot we do not know about the oviduct, actually. Experimentally, we were capable of inducing diffuse peritonitis within 2 days with some of these E. coli, particularly ST95 is very virulent, and 10 to the 6 bacteria will result in this in 2 days. What we also were capable of see when we compared, because a model, of course, should be able to differentiate between different types and demonstrate different virulence properties. And again, we used high dose and low doses of 2 subtypes, ST95 and ST141. And we had seen in the field that ST141 was not very virulent. We saw occasionally single birds, but never outbreak associated. However, ST95 in Denmark is commonly isolated and result in more or less outbreak of salpingitis, peritonitis, and septicemia. And what we saw in this model, using 10 birds within these groups, was that this is a score of lesions you see out here, made a scoring system, is that ST95 is significantly more virulent in this model than others, and of course in 141. So we finally felt that we had a tool here to investigate some of these subtypes of E. coli and what they were capable of. We could also see when we did some histopathology, no lesions, of course. This is the liver and the salpinx, and we do see histopathological lesions of the oviduct and the liver with this high virulent ST95. And to my knowledge, this was the first time anyone was really looking at, again, histopathological lesions of the oviduct. So it's been very nice for us to develop this. We have expanded now our investigations because, again, what we find, for instance, in ProHealth, where we see some of these subtypes, again and again, a few of them, we would like to find out what are they capable of. Are they more virulent, or are they just better surviving in the environment, or something like that? So a recent study, we also compared broiler breeders with layers and the susceptibility for E. coli, and included different strains. A strain, as you saw, ST95 being very virulent, and septicemic isolate, swollen head syndrome isolate, a commensal not associated disease, and a chronic salpingitis isolate. And we used it to inoculate both layers and broiler breeders. And again, I'm not going into detail about this, but we can definitely differentiate. And what was very clear for us is that the broiler breeders are more susceptible than the layer birds to these infections. This is again a cumulative lesion score you see on your left, and you can see a lot of the birds with higher scores than the layer birds in some of the organ systems. Just underlining again that the E. coli infections, well, it is about the bacteria, the E. coli, but there are also host susceptibility differences, genotypic differences. And it fits very well what we've been seeing over the years, that the broiler breeders are more susceptible to E. coli infections. We see outbreak of this type of mortality. That's very rare. We see that in the layers. So it makes the situation very, very complex. This was underlined of the bacteriology because here we re-isolate the E. coli that we inject from different places in the layers on top, the broiler breeders. And as you can see, we have a much higher recovery rate in the broiler breeders, demonstrating that the infection is really manifest in these birds. Finally, just to show you that there's a good correlation between this general virulence of the isolate and the ability to affect egg laying. Because the same isolates you just saw before, this is the broiler breeders again, you can see the drop after the infection of the oviduct. The orange is the ST95, which is very virulent, and we also have a severe drop with the green, the swollen head, but there are differences. So actually, it looks as we have several parameters now we can use to get a characterization of the capability of the different subtypes of E. coli. And when we are capable of doing that, it will be possible to say actually more about the findings in the vertical transmission study. Why are some of these subtypes of E. coli transmitted more frequently than others vertically? And what does that mean for the outcome at a later stage? I think I have said most of that, so I'll just say thank you.